Hello and welcome to another free code session. My name is Jason Bach. I now have 8.0.0 of rocks available. I did this, if I'm doing the math right, about a week ago. It's near the end of January when I recorded this video. So it's been out for just a little bit and we have 102 downloads. So it's not a ton. As I've said numerous times before, on the one hand, it'd be really nice if more people used it. On the other hand, I understand why. And there's always the underlying justification of this is a great way for me to explore things, to try things, to improve things. And that's really the main motivational force behind all this. But again, if people wanted to try it, I'd be absolutely all for it. And I've also started to think a little bit about looking at the other mocking frameworks and seeing what features they have and to see if maybe I should introduce some of them. I've been a little leery of doing that because I also like rocks being minimalistic and giving you what you need for mocking without a ton of extraneous features that you may or may not use. You know, mocking itself should be something that you don't do as a habit, in my opinion. It's nice when the tools are there to support when you need it, but you can really fall into a trap of overusing them. So as with anything, use the right tool for the right job, or more to the point, use the right tool at the right time, which is probably the same thing. But in any event, I'm very proud of this being out there. The BenchmarkDotNet tests project has been updated, the repository, but I don't think he's run the latest benchmarks for it just yet. In fact, let's go take a look at that right now. If I go to BenchmarkDotNet and I go to the results, I believe it's from a couple months ago. So hopefully he does that, because it'd be nice to see these results get even better. So that's where Rock stands right now. I've already thought of a bunch of things to do in the next minor release with some features and things like that. One of them, there's a lot of them, and part of them are going to be focusing on the creation of the mocks, the actual generation of the code. I have the feeling I am doing some very unoptimistic things or more, no, that's the wrong word, unoptimized things. And I know, like, when I run code generation tests, angle sharp for some reason takes quite a long time for it to finish. I don't know why. And so I need to dig in and figure out where I can make some improvements. So it's definitely one of many things I'm going to be looking at in the near future. But one of the first things I wanted to do is this idea, and we're going to be doing some benchmarks. So this is this idea that I have these lists of handlers. For most of the time, I'm probably only going to need one expectation made per member, and maybe one or two members at that. They really don't need to be made that often. Typically, that's not, there are cases where you would make more, but for the most part, it's usually just make an expectation or two and then you're done. Okay. So I wanted to look in to see if there's a way to kind of optimize this. And one of them is, again, I'm going to go back to the source of truth, source.net. I love saying that. Let's go to list of T. I believe when you say a new list, it doesn't put anything in it, but then when you say add, I believe what it does then constructs a list in its capacity. Upon adding the first element, it increased the default capacity, which is 4. And that's what we're trying to avoid, because when we add 1, we automatically add 4. Or more, we don't add 4, we allocate an array of 4 elements. And yes, 3 of them are null. 3 of them you never use because it's being wrapped by the list that really says, nope, there's only 1 and it's at the 0th index. But I'm like, I don't even want that. I want to see if it's possible to initialize the list, because there's a collection here. And I think what this will do, if I follow the code correctly, and I could be wrong in this, is it will take whatever you pass it in as the enumerable and set your, if you have something, it will set items to a new array of that size, that particular size, and then copy in that. So my understanding is this will give it a one element array of what you just passed in. And so if you look at my issue here, I'm saying, let's try something like this and see what happens. Yeah. Now, after that, there will be, if you had another one, it will have to double it. And then if you get to 4, then it would be the same as if you started with an empty and added 1, because then that's going to get allocated to 4. So it's always a doubling thing. So the drawback of this is potentially if you wanted to do 2, well, now you're going to have to add 1, and then we have to do a reallocation of that array. You know, this is, as I put in my notes here, this is a very micro optimization at best. And arguably this isn't even where I should be spending my time, but I'm curious. You know, I wanted to just check out this idea and see if it made any impact to the code itself. And then I had an idea where basically I thought, could I use a forward only linked list? And linked list, I don't even think is a type in .NET proper. And I, if I remember right, I could, you know, I'm going back in the memory banks here, but I don't think if I said linked list, there is one. Yes, system collection linked list. It's a doubly linked list. So it, this is where I think I put a, something on Blue Sky in Mastodon that said, you know, stand back, I'm going to be doing some performance measurements on a data structure and I don't even have a comp sci degree, so things could go terribly here. I believe with the linked list, when it says it's doubly linked, it means it's links back and forward. Long story short, I don't need that, because with the handlers, you just keep adding. You add a new handler, you add a new handler, and then when you're going through it, it's forward only. You start at the first element and then you just go all the way to the end, and that's all I need. So I don't want to use a linked list because I think if I remember right, I've heard that its performance is typically not the greatest. I should have looked that up before I started recording, but if I remember, I'll put notes in the next episode to talk about that if I find anything that's relevant to the point. But what I thought is, could I create on handler a next node of the handler type? Now that may break this because you want to have the next be of the self type, so to speak. And if you do that here and the node is defined on this base type or one of these base types, I don't think it's going to work the way I wanted it to do. I think I ran into that with something else. And that's why I think with the adornments, or there's some other type that I had to have separate ones. And I don't remember off the top of my head which one was it. Was it adornments? I don't think it is, because yeah, maybe it is, because there's an adornments that, and this one doesn't derive from this one, even though this adornments has pretty much everything you need except the return value. But because of the way it needs to do the fluent interface and return things, I kind of went, it just didn't end up working correctly because it wouldn't return the adornments of 3 generic values. It would return the one of 2 because that's where it's defined on here. So I don't think that's what I would want. I would have to put I'd have to break the inheritance structure here and then put a callback here, but it's not that big of a deal. I mean, it's pretty straightforward to do that. And so what I would do then is have a handler list type or handlers type. And all that would do is when you create it, it takes a reference to a handlers. And again, they're all the same type when you pass it into this handlers type. Because right now we have a list of a specific handler type. So it's the same thing. It'd only be of one handler type. And so you add the first one, and then you also keep a reference to the last one you add. And in that case, when you start, the last one is your first one. And so any subsequent time you add, you just take the last one and set its node to what you just passed in, and then that one becomes the last one. And the way that just they all link up, so as long as you have the first one, you're fine. And then I can create an enumerator off of that just keeps going through each one and seeing where to get to the end. The advantage of this is potentially less memory and maybe faster, but I don't know. I really don't know if this is going to be any better or not. So that's why I just want to spend some exploration time trying this out. So I've got a branch set up. I need to basically create some benchmark tests. I am going to have to tweak handlers here a little bit. In fact, while I'm here, let's do that right now, because we're going to want to put this here, and then we don't have that there. And we want this, though, to still derive from handler there. And that should be fine. And then we want, yes, we're going to want here now a public handler of t callback question mark next. And that's mutable. Gets or sets the next handler to visit. And then we do the same thing down here, except in this case, it will be t return. Okay, now let's write some benchmarking code. This may have broken everything I've already put in place. I don't really care about that right now, but I would have to care. You know, part of me says, well, I should test this. Just run all, you know what? Hold on. Let me actually run the tests here and just to see if this broke anything or not. It shouldn't, but let me see. Okay, it didn't break anything. So that's good. All right, that's good enough for now. So let's go into code generation. No, not code generation tests, integration tests. Non-integration tests, performance. I got to clean this up. I feel like I overdid it with performance because a lot of this I'm just, you know, I wanted to like have test for test to make sure that what I'm doing is actually what I expect it to do. But I think that's a little bit too much. That was a little bit too much. What is the integrate? Like, I don't even know why these are. Oh, that's right. Is it? Yeah, I can't honestly for the life of me now figure out why I have one over the other. It feels really wrong, or why I have so much here. I'm just looking to run tests, and if I need to make sure that they're giving back the right values, I can just put something in the console app real quick and see, did it print out the right things, and that's good enough. So this, I think, is what we're going to just stick with, rocks performance. So what we want to have here is handler lists, because why not? Handler lists. And what we're going to need also is just a simple implementation of a handler from a public seal class. Handler int. Handler. Can I spell handler? Handler int, which would be a handler of a func of int. So the thing we're targeting is actually taking int, returning an int, and then the return type would be an int. There. And technically what we have on these, if I remember right, is we end up having arguments on them, right? So we would have a public argument of int, we'll just call it input, and that's a get in the set. Because we put, I just always love when I go back and think, what did I do? So we put that around everything. That shuts it up. And yeah, that's it. Okay, cool. And then we would just put a restore here. I just need something that mimics what we have. Okay, so the benchmark, and this is the baseline. I think that's true. I always do that. And then we love our memory diagnosers. This one will be public int add int count. And the reason I'm doing this is because I want this to be parameterized. And I was thinking about this because the way this works is I have fields that have all the lists of arguments, and then I just keep adding to them. But this would be a little bit tough because I would need to on not every invocation, but on every, well, maybe I could do that. Maybe I could say private read only list of handler int handler list default, because that's the way we do it right now, and make that a question mark because we don't have it set yet. Oh, and then we need this to be that because otherwise you couldn't you couldn't actually set to it. So what we want to do in the add default case is say for each var for I it's a Sunday morning. Have patience on all of us. Okay. So again, to mimic what we're doing right now is down here. Blah, blah, blah. We get a handler. We're going to create a new handler. So we're going to say our handler is equal to new handler int. And then we can say input is equal to that should actually work. Yeah, because we have how does that work? Is because we have implicit conversion. Now, the way we didn't have the cursor in it. We want to do something like that. This is the code we really want to test. So we want to say if this dot handler list default is null, then we set this to a new, and then we do that, and then we return the length count. Okay. Use compound assignment. Oh, that's even smaller, and I like that. It's exactly the same thing, but it's less code. If anything, I'm going to change on how to do this because that's actually nicer. And then, I'm sorry I'm laughing so hard. Tell me if you were a C# developer 20 years ago, you would have ever written code that looks like what I just highlighted. That looks insane. That looks just like, what in the world did I just write? Okay. But what I'm going to do is back this out and just say to do the new hotness. That's what we want to do. Okay. And I think the code will translate exactly into the same thing I'm showing here. But then that takes all these places where I'm doing that, and changes it into just that. That's it. Well, I mean, and there's a level of indirection because it's on the expectations, but that's fine. So I'm sorry, that just made me laugh really hard. So, okay. And then we have to make sure that, yes, we did check it. We are checking that's not null, but we can assume it isn't at this point. So that's the default. Now, I don't know in this episode if I'm going to get to the linky list idea, but we're going to do this add with one initialization. And so in this case, what I want to do is say, let's go back to what I wrote in my write-up. So I want to say new, except we're going to pass in the handler here. Now, this also could use compound assignment. So we're going to make sure that we have this. We can't make an empty array, obviously. But we can do that. Okay. But we're going to, well, stop it. Let's keep this. Back it up. Nope. There. And now this. There. Okay, cool. And am I in release? Okay. So this should, in both cases, no, oh, I'm sorry. I never added the parameterization. So this is where I want to have something being passed in to, I don't care about arguments. There we go. So I could say here. I could do it that way. I could just hard code them, but I like where arguments source. Yes. And that's what we want. A little awkward, but, oh, we can't make this 2 baselines. I always do that wrong. Yeah, I know. You don't know what data is. We're going to call it sizes. I never have liked with BenchmarkDotNet this way of doing parameterization of values, but it is what it is. It feels hokey. But what we want to do is we want to do an object array. I'm trying to see if you can actually just pass in. No, you have to do, fine, whatever. Yield, return 1. What is your problem? I don't think it matters if it's static. Oh, and then we want 1, 2, 5, and 10, just to start with. I'm going to pause this. Well, can we do this first? Let's make this the startup. And then come into program here. Get rid of all this. Handler lists, because that's what we want to run. But before we do that, let's just say var list is equal to new lists. Console right line lists, add default 4, and then add with 1 initialization 4. Well, ain't that cute? 4 and 8. Why would you do double? Oh, that's why you do double, because I'm an idiot. And 1 initialization there, because I am stupid. That's why you need to test your code. 4. Okay, let me just run this once with the way it is, and we'll see what this does. Okay. Before I ran it, I realized this was also wrong. So I had to change that too. So just to be really sure, for 5. Oh, that's right. That's right. I am showing that maybe I should keep my test app, because I have where here. Yes, you need an else here now. You can't do this. You have to say else that. Now, if I run it, 4. Okay, now I'm going to run the tests. Well, this is why you do benchmarks. So I changed the code a little bit. I think by having them as fields, even though I had global set up, I don't think it was actually getting rid of what was currently there. I really don't know. Something didn't seem right. It was taking forever for them to run, even after I turned off the recording stuff I use. So I changed it so it just puts the nullable list inside each of the methods, and ran the tests. And what I saw was this. Where is it? Here. So this is not a good technique to use. And it doesn't truly surprise me, because you have to allocate something and pass it into the lists constructor. Now, I don't know what it's allocating there. I think it's probably a list, because they say they always are trying to find the most, the one that's going to cause the least amount of performance problems. So I would imagine that's what's actually being passed in as an array. But I really don't know if it's an enumerable. I would imagine they do something like an array, because that would be the most efficient thing to do. But in either case, because the fact of you have to create something and then pass that in and then copy, it doesn't surprise me that it takes a little bit more memory and a little bit more time to do that, even though you end up with what you would hope would be less allocations. It's actually not. So not entirely surprising, but this really wasn't the one I was going for. It's the one about trying to do the forward only linked list custom implementation. We'll see if that's any better or not, but I will be doing that in the next episode. Thank you all for watching. Leave comments and questions below. See you in the next episode.